Hello students, and welcome to part 3 of our dimensional analysis notes. For these notes, we are going to learn how to solve for squared and cubed units. So to start this off, let's just ask a simple question. In math, what is the long way of writing x cubed? I think a lot of us have seen this before, where x cubed is just the same as x times x times x. So keeping that in mind, what is the long way of writing centimeters cubed? Well, it follows that same idea. Centimeters cubed would just be written as centimeters times centimeters times centimeters. That's going to be important to know while we're going through and solving these types of problems. Before we just dive right into solving these, I actually want to explain a little bit more with real-world examples as to what these are and what the difference is. What does centimeters cubed mean? So, what is the difference between centimeters, centimeters squared, and centimeters cubed? Well, here's an example. If we have this line, and the line just has length of L, we can just say that that line is equal to x. So therefore, the length of the line is equal to x. That example is almost so simple that it's confusing. So let's take a look at what squared would mean. So here, if we have a box, the area of the box is equal to length times height. If we want to call this bottom line L, this line running up and down our height, and both of those, since this is a square, we're going to assume that they are the same length. So if this is length x, height is also length x because it's a square. Well, in that case, area of a box is just equal to x times x, which is the same thing as x squared. Okay, and notice this line was a one-dimensional shape. This is a two-dimensional shape. That is, it's just like a flat box. And then we could also add in a three-dimensional shape, which is going to be the volume of a cube, which is length times width times height. So if we want to call this our length, this our height, and now this back line our width, we can again apply this variable x to those lengths. So if this is a perfect cube, if this side is length of x, our height is also length of x, and therefore our width is length of x. So what x cubed is just x times x times x, which is x cubed, so a three-dimensional shape. So the important differences between these is that 1 meter is equal to 100 centimeters. You can look at a meter stick and you will see, yeah, 1 meter is equal to 100 centimeters. That's absolutely true. But what happens a lot of times is students will think that 1 meter squared is equal to 100 centimeters squared, or that 1 meter cubed is equal to 100 centimeters cubed. We need to make sure that that doesn't happen because this is absolutely incorrect. 100% this is incorrect, and I want to explain why to ensure that you don't make this mistake. So again, 1 meter squared does not equal 100 centimeters squared. 100 meters cubed does not equal 100 centimeters cubed. But it is true that 1 meter equals 100 centimeters. So let's figure out what they do equal. But first, let's just start off so we can all agree that 1 meter equals 100 centimeters. Again, if we have this line, and the line has a length of L, well, if we just said that x is equal to 1 meter, we can also say x equals 100 centimeters. Yeah, that's absolutely true. So therefore, 1 meter equal to 100 centimeters. Completely true. So let's take a look at why 1 meter squared does not equal 100 centimeters squared. Again, we have the box, and the area of a box is equal to length times height. So if we have our length, we have our height, well, let's go through and assign some actual length to it. Let's say that this side is 1 meter. That means that this side is also 1 meter. Well, we said in the previous slide that 1 meter is the exact same thing as 100 centimeters. So therefore, if this line, L, is 1 meter, it's also 100 centimeters. That's absolutely true. Same thing for our height. If this line is 1 meter, it's also 100 centimeters. Absolutely true. But what happens now is when we're solving for the area of the box, that length and height are going to multiply. Therefore, there's still x. This is still length x, still length x. So therefore, the area of the box is x times x, or x squared. So let's actually go through and solve for this box. Using meters, we know the area of the box is length times height. Our length was 1 meter, because that's the units we're going to solve for. Our length was 1 meter, our height was 1 meter. And what you do when you multiply these is you actually have to multiply both the number and the units. So I like to just kind of split those apart. Therefore, 1 times 1 is equal to 1. Meters times meters, we've already said, is equal to, like you can see over here, x times x is x squared. So meter times meter is meter squared. So the area of the box is 1 meter squared, and that makes sense when you think about it. You have a 1 meter square box. Now, remember, what we're trying to show on this slide is that 1 meter squared does not equal 100 centimeters. So let's go through and solve for this using centimeters. We're going to do the same process. Area of the box is equal length times height. Remember, the length of the box is also 100 centimeters. The height of the box is also 100 centimeters. So therefore, 100 centimeters times 100 centimeters, you're going to get 100 times 100, and centimeters times centimeters. Well, 100 times 100 is 10,000 centimeters squared. So while this box is absolutely 1 meter squared, notice it is 10,000 centimeters squared. And what that means is that if you had a 1 centimeter squared box, it would take 10,000 of them to fill this giant box right here. And I'll go on and show you a real life example later in this video. But what this ultimately means is that 1 meter squared doesn't equal 100 centimeters squared. 1 meter squared equals 10,000 centimeters squared. Okay, let's go on and show the same thing with meters cubed. 1 meter cubed does not equal 100 centimeters cubed. So looking at this cube, we have the equation length times width times height. So we have length, we have width, and we have height. We're going to do a similar process we did before. If we call this 1 meter in length, and this is a perfect cube, then this must be 1 meter in width and 1 meter in height. Therefore, this is 100 centimeters in length, 100 centimeters in width, 100 centimeters in height. And if we call all these x, because they're all equal to each other, we get this equation that x times x times x, also known as x cubed. So let's go through and solve for this in meters. Volume of cube is length times width times height. Therefore, it's 1 meter times 1 meter times 1 meter. So 1 times 1 times 1, meter times meter times meter, and you find that the volume of this cube is 1 meter cubed. Absolutely. This cube is 1 meter in every direction, therefore it's just 1 cubed meter. Let's solve for this in centimeters. The volume of a cube, again, length times width times height, well, it's the same thing. This length is also 100 centimeters. This width is 100 centimeters. This height is 100 centimeters. So therefore, to solve for this, we get 100 times 100 times 100, and centimeter times centimeter times centimeter, which gives you the volume of this cube in centimeters is 1 million centimeters cubed. So again, 1 meter cubed is absolutely not equal to 100 centimeters cubed. 1 meter cubed is equal to 1 million centimeters cubed. And now I'm going to show you a real-world example and explanation.
All right, to give some real-world examples here, let's take a look at a meter stick. So if we look at this meter stick, that is, it's 1 meter, we can see that it's broken apart into these centimeter increments. So 1, 2, 3, 4, 5, and we can go all the way down to 100. So therefore, we can say that 100 centimeters is equal to 1 meter. It's absolutely true. Now let's take a look at what a centimeter squared is and what a meter squared is. So if we come over here, a centimeter squared, remember this is two-dimensional, is a square, so we're going to focus on just the face of one die, The face of one die is about 1 centimeter by 1 centimeter. So therefore, we take our length times width, or whatever you want to call it, and we get the plain die has a face of 1 centimeter squared. Let's take a look at what a meter squared is. A meter squared would be this entire square. That is, we have 1 meter by 1 meter. And if you look in there, it's going to take far more than 100 of those tiny little dice squares to fill this entire box. So never say 100 centimeters squared is equal to 1 meter squared. That's not the case. It's going to take 10,000 of those squares to fill this giant square. Now let's go one step further and take a look at what cubed means. So if we come back and look at cubed, cubed just means we're going to look at the entire plain die. Again, it's 1 centimeter by 1 centimeter. But now we're going to make this a three-dimensional object, and we have another centimeter there. So therefore, the entire plain die is 1 centimeter cubed. Let's compare this to a meter cubed. A meter cubed is going to be this. It is 1 meter by 1 meter by 1 meter. So you have your length, your width, and your height. So this is a meter cubed. You can clearly see it's going to take more than 100 of those plain dice to fill this 1 meter cubed, or this 1 meter box. In fact, it's going to take 1,000,000 of that little plain dice to fill this entire thing. So again, what I want you to take away from this, 100 centimeters cubed is not equal to 1 meter cubed. 1 centimeter cubed is this little die. 1 meter cubed is this giant box. It's going to take 1,000,000 centimeters cubed to be equal to 1 meter cubed.